Hello everyone and welcome to a fresh discussion on groundwater exploration, and this is part 13 and here we are going to discuss sampling. Why sampling? Because after drilling, as we have been discussing during drilling methods, that cuttings are recovered. The rock pieces which are being cut by drill or different methods of drilling, they have to be brought on the surface and should be cleaned and preserved, so that this becomes a reference at what location what kind of formations are there, and at what location the water table was found, and at what location caves have been found, small cavities have been found. That kind of information has to be stored, because remember one thing, when we were discussing about exploratory drilling or test drilling in section groundwater exploration part 11, and there we said that this is, since it is a expensive option or a expensive operation, that is the drilling, and therefore the maximum subsurface information should be extracted. And one of the important subsurface information is about the formations, what kind of formations are there, which type of formations are there, what is the thickness of these formations, and if there are some caves or some loose sediments, clay and other layers are there, that information has to be stored. So, how the speed of drill is also recorded, the materials which is coming also recorded. So, in this we are going to discuss the sampling methods. So, a person or a driller or a geologist who would be present during the drilling operations is completely responsible for preparation of accurate lithological logs or records of sample at from what depth has come, and would keep in a proper drill these log box also. So, this keep coming, say if a drilling is quite fast, then this material keep coming, that has to be cleaned and should be kept in the boxes accordingly with the depth. So, that a driller will keep putting information, observing the drilling rate, drilling sound also. The expert drillers or a site geologist can assess based on the drilling sound, that what kind of rocks are being encountered by the bit at a certain depth, and a smoothness or roughness of penetration, how fast, how it is going, what kind of vibrations are there, and relating them to the lag time in appearance of samples at the surface from the depth drill. So, depending on kind of material it is being drilled, the time which it would take to come up will also depend on the material. So, this lag time is also recorded. So, everything is basically recorded, because it is expensive. Again, it cannot be done on the same site or in nearby places, and therefore, maximum subsurface information should be collected, because it is a very expensive affair. When drilling is fast and smooth in sands generally, very slow in plastic and sticky clay layers, rough with crunchy or rattling sound in pebbles, if you get these kind of sediments, and larger size materials are there. So, this can be, if somebody is adopting these drilling methods, fast drilling method, air rotatory, reverse rotatory and so on, in a Indo-Gangetic plain like situation, then this kind of scenario might be observed. Now, bit conditions and ability of driller also influence drilling speed. So, expertise is required, that not anyone can do it, but expertise is required, that is the ability of driller will also influence the drilling speed, in what way he put the compressed air and water and so on. So, depth at which the caving is a serious issue many times, and a mud loss occurred. That has to be also how much mud is being put, at what rate it is being put, whether if it is not coming properly after a lag time, then there must be some loss, and this mud loss might be because of caving. So, was added or old mud removed, because the same mud cannot be used for the entire operation. So, sometimes when mud becomes bentonite or mud becomes unusable, then it is changed and a new mud is brought, but the viscosity of the mud should be maintained, otherwise you would get a completely different thing. So, all these things are also recorded, the viscosity of the mud is also recorded, the mud which is being sent and the mud which is coming out. So, viscosity of both types of muds, and after some time it it goes beyond the limits, then it is changed, removed. Now, the color of mud, the texture, granularity, mineralogical composition, acid reaction should be described and related to their in situ depth. So, all these rock pieces which are coming, their all kind of characteristics are recorded immediately. Otherwise, things will get disturbed in time, and then it becomes very difficult to get all that information which was desired through a expensive operation. And it may also be important that large grains do not appear on the surface till they are broken down to the sizes. Otherwise, they will keep moving. So, that is another issue. So, can be carried upwards, and finer grains are suspended in the circulating drilling fluid. So, this kind of problem will be there, and that large pieces they might be broken later on, will have some delay or lag time also. Drilling fluid thickens while drilling through clay and thins permeable water bearing zones under pressure. If water is found, then the mud which is coming, the viscosity will reduce, and a expert driller will immediately tell that he has encountered the groundwater table. That kind of expertise is required. Just looking the viscosity of mud, he can assess lot many information. Now, these the samples or cutting samples should be collected at every 1 to 3 meter intervals, and whenever there is a formation change. 1 to 3 meters, because these boxes are of that length generally. So, that is why after, not after every inch of material or every piece of material is being collected, but at certain intervals 1 to 3 meters. So, because we cannot keep each and every thing which is coming and preserve. Representative, basically what we are looking, representative samples which should be, and their depth is also recorded, and what kind of changes in the rock or formations are there to ensure the representativeness of sample. Just mention this thing, and drilling may be stopped and the whole flushed of accumulated cuttings by continuing fluid circulation. So, sometimes that step is also taken, the drilling is stopped, but the fluid is keep going and to recover whatever the rock pieces are there inside the hole. So, the direct circulation methods are there, the samples are caught in a sample catcher as a fluid flows out of the hole. So, and also quantities of samples should be collected in proportionate to the bulk of various grades from the entire length of the sample catcher. The purpose, as I have been saying, the purpose here to record, have a representation or reference, for reference purposes, maximum things should be recorded properly. Now, in other methods, like we have seen rotatory methods, reverse circulation methods. So, in reverse circulation method, samples are caught in a bucket or a drum at the end of discharge pipe. So, first it will be brought in the discharge pipe, then from there it can be collected. So, they are washed first free of drilling mud and dried, and then properly they are kept in the boxes. About 2000 cc of material after quartering and coning is preserved in containers of polythene bags for further test. If very fine material is coming, where rock pieces are not coming, then these samples are kept in the polythene bags. But before that, quartering means quartering and coning method. That means that if I am getting the loose material, and then I have to preserve the representative sample. Therefore, whatever the for certain period of time, whatever the material has come, that has been divided, that will be divided in 4 parts through a quartering and coning method, and one of the samples, so that it truly becomes a representative sample, is kept for reference. And for designing of water wells, mechanical analysis of granular formation materials should be carried out. So that we would like to know what would it yield. It will yield the grain size distribution, and when we measure these grain sizes of the different sediments or pieces which are coming out, which will give us a curve which will prepare before pilot hole drilling operations are completed, and that these things are done almost in near real time. So that the information which is being collected gets, and then next step is taken accordingly. Now source water, which is used for preparing of drilling fluid, mud samples before the commencement of drilling and at the interval during the drilling should be collected. That means we should have enough reserve of water for this operation, and again the quality of that water should also be tested. So, EC values of the source water, mud filtrates will give preliminary information on the existence of saline zones, if any, within the intervals drilled, because when the water is coming out or mud is coming out, the viscosity may change because of if water is the source water which is being put in the hole is having some salinity or other things also. So, in this sampling case, finally the information gathered is sometimes may not be adequate for the recommendation of construction of a test well or production well. Then geophysical well logging or preliminary testing will have to be resorted, and that is almost the final in the groundwater exploration, that once a hole has been prepared, whatever the method which has been applied for drilling, all records have been kept, all references have been prepared. Now, still we may not have the adequate information required for a test well or a production well. Production well, this term is also coming from the same in oil industry also, or in for water also. So, if before finalizing, because as I was saying, for domestic consumption for one house or two or some colonies, such kind of expensive solutions, geophysical well logging may not be required. But if it is for industry, then all these methods have to be adopted, because for industry, for certain type of industry, continuous water supply is required, and therefore after the drilling, then geophysical well logging will also be required, so that the well becomes highly reliable in terms of productivity. Now, in this source water which we prepare for drilling fluid, mud samples before commencement. Now, the preliminary tests are done on the pilot hole itself, or after reaming or widening. It is the minimum size, that is usually smaller than the final production well size. So, this is usually smaller. So, you start say with the if I give example of a 6-inch, then the final bore hole may not be having exactly 6-inch, it may be less, because the casing pipe might be going some, and when pipe is put, it is not all the time touching the all walls. So, therefore, it would be smaller than the original hole which one was intended. So, the final production well size would be smaller. So, depending on the requirements, accordingly a hole is made, the diameter is chosen, so that we get depending on the final production well size. Based on that, the driller will decide that what kind of diameter of bit should be installed in a rig. Now, further tests are required. That zones to be tested are hydraulically isolated, which is done by judicious combination of selective development, use of packers, gravel packs and other things, drilling mud which is used, and of course, the casing. As we have discussed, in completely hard rock terrain, casing generally may not be required, but in unconsolidated cases, casing will be required. And discharge and quality of water are determined before finalization of a production well also. If favorable conditions are established, and then well assembly is designed and the borehole reamed to be desired diameter and depth. And the well assembly means basically installing a pump. And typical well assembly basically consists of housing pipe to accommodate the pumping unit and water level changes, if that kind of recording is also required. A production string consisting of perforated pipes for placing against aquifer and blank pipes, and also a length of blank casing, and with a closed bottom or bail plug. Sometimes it is also required. So, at the bottom you plug it, so that nothing will come from there, or the water which has filled in the that blank casing will remain there, so that when pumping is done, that water is also available for use. Several considerations also go into designing a well assembly so that it meets the requirements. This requirement is prime importance, especially for industries, may not be, or for agriculture things, but may not be for domestic purpose, but still for domestic purpose certain requirements are there. And this test requirements and produces an optimum yield, the required yield with trouble free performance and at economic cost. So, whenever a well is being finalized for production of water, then all these things are considered, that how much yield, optimum yield I am going to have, the performance of the well pump, all assemblies should be good, trouble free for a very long time, and there should not be lot of cost involved. Otherwise, the things will become difficult for a industry or a organization or for a individual also. So, these consideration includes the provision for housing, for sealing saline zones, sometimes one may encounter this kind of problem, screening aquifers with appropriate size. So, all pipes are not blocking pipes, means some pipes at certain length where water is available in aquifer zone, these are perforated, and that pipe, that is called the screening. So, there the screening screens should be present in the pipes, and this is in case of unconsolidated materials or rocks formations, but in consolidated rocks like in hard rock terrain, such things may not be required, but screening pipes are required, and then we have to choose their size and designing of screening also. The area of screen opening, how much is opened towards the formation so that water can enter into the well. Also, we should know what kind of gravel size for packing, because pipe and the well there might be some packing required. So, that gravel size has to be of certain type. Now, basic hydrological data required for well designs are the depth to water level, at what depth you are getting the water level, aquifer intervals and grain size distribution, if at all that grain size distribution in case of unconsolidated materials, and at what depth the aquifers are getting, confined aquifers, unconfined and so on, that is why aquifer intervals, probable discharge and drawdown, and that is tested before the finalization of well. So, a pump may be run for 1 day or 12 hours or overnight something to assess the drawdown and of course, the discharge, how much yield it will give. So, when we have been discussing the pumping test, this part we have discussed in elaborated fashion. So, that I am not going to discuss here. Now, water level declines, how water level declines in future from all causes during the lifetime of well. So, like one decline which is annual decline, that is pre-monsoon and post-monsoon. There might be decline also diurnal decline in early morning and late evening. Remember that whenever the water level is measured for groundwater purposes, it is generally recommended that it should be done early morning, maybe 4 o'clock, 4:30 or by that, because the overnight the well is left, so that whatever is the recovery is there, it will happen and then you get the exact. But if a water level is measured in noon time, then you are bound to have generally a lower water level. So, that will give you a wrong idea, that is why it is there. And of course, the quality of water, formation water or water which is coming from formation has to be assessed there. Now, if we do not correctly choose the screen pipes, because this will depend on the type of formations which are present inside a well. So, a driller will also advise you as per his own experience and knowledge that what kind of screens are required, so that your well give good performance and does not fail. Because otherwise, say after so much of investment and if desired output is not coming, just because of screens, that would be a very wrong thing. So, in order to avoid, appropriate screens as per the subsurface materials have to be adopted. Once the zones to be tapped, the area from where the water will come, the aquifers generally, are decided, then two options arise. First, a constructed natural pack, and natural pack by gravels pack, or gravel pack bells, natural or other pack through mud also in some parts where the screen is not there, that can be done. But the most common practice is do by the gravel pack. If this is also assessed, uniformity coefficient is important here. If this D10 and uniformity coefficient of aquifers are respectively greater than 0.25 mm and 2 screens with openings corresponding to D70, these are the diameter of the size can be selected, and a well assembly suitable length of blanks and screen lowered into the hole. So, in case of unconsolidated materials, the diameter, that means the grain size of the sediments which are present in subsurface have to be assessed. And that is why when in the beginning of this discussion, we have discussed that if it is unconsolidated horizons, then the grain size is also measured. And if that has been measured properly, this will help us that what should be the opening size of any screen, what should be the diameter of that. So, there these are the diameters in millimeter which are considered here. So, D10, D40, D70, accordingly the size of sediment which are present in subsurface conditions. So, that suitable length of blanks pipes and screens lowered into the hole. What the purpose here is that only that part will have openings through screens of aquifer which can provide water into the well, and other parts would have complete blank pipes, no water will enter from there, and in any way that water is not there. And these are more common, this kind of arrangements are more common in unconsolidated formations. But in hard rock terrains, drilling is expensive, but this well assembly is not as that expensive. Not much piping, screening, and these assessments are required. So, it is important to note that a natural pack well, there is a little option but to change the size of the screen slots. So, the gravel pack or whatever the packing which we are doing, we should keep in mind what kind of screen size is there. That means the pack should not enter into the well. That is the purpose. So, the opening in the screen should be smaller than the gravel pack. So, criteria for selecting gravel pack material, that is uniformity coefficient of aquifer material, that is less than 2.5. Gravel pack criteria is this uniformity coefficient UC between 1 to 2.5, and screen slot size is less than 10%. And accordingly, in case of uniformity or UC is 2.5 to 5, then less than 10% passing size at gravel pack. But UC between 1 to 5 with 50% size not greater than 9 times the 50% of the aquifer material. And here if it is less than 5, then again multiply by 30% passing size of the aquifer material. And the main purpose, as I have said, the material beyond the screen which is present in the well should not enter into the well. Otherwise, when you pump out the water, that material will also come. But material may not be problem, we can filter it, but that means it is doing scouring in subsurface conditions, and after some time the well might fail, and therefore the larger materials should be kept outside the screen, and that can be only controlled by this uniform coefficient or the screen size better. So, wider choices of screen size and designs are possible by providing artificial gravel envelope between the well assembly and the whole well. So, if it is say this is the well and this is after the pipe is there. So, this part can be filled with gravel pack, and the size of material or gravel should be larger than the screen size openings. So, gravel pack envelopes increases the effective diameter of the well. It will reduce of course the diameter of the well and retain, but it will long lasting, the well would be long lasting, the performance of that well is going to be high. It will retain the finer materials from entering the well. That is very important. After lowering the well assembly, that includes pipes, screen, and of course later on the pump, the zones with an inferior quality of water have to be sealed, because at some certain horizon you may not be getting good water, and in sometimes you might be getting contaminated water because of unconfined aquifer conditions which are being recharged by some contaminated water which are around industry or something. So, that part has to be sealed with cement grout to avoid any kind of contamination of fresh water which you are going to extract from greater depth. So, that is why if you remember, the water which is coming during the drilling, the quality of that water has to be tested. Every time it has to be basically monitored at that time. So, you would know exactly at what depth you are getting a contaminated or saline water, at what depth you are getting fresh water. So, the zone which is providing contaminated or saline water has to be sealed, and that sealed can be done, that sealing can be done by doing cement grouting. And wells should be cleared of fillings and developed to remove clay and finer particles around the screen to improve permeability of aquifer. So, finer particles should be removed, that means either by water or air, especially by putting water and running for a long time, all the finer materials will come out. So, what is done basically after the drilling, the temporarily a pump is installed and water is taken out for very long time. So, initially you would get water with lot of relatively large and very fine sediments or material, but after running for 10-12 hours you would start seeing that the water is coming very fresh. So, all that material, smaller materials will at initial stages of that will come out, then assembly is lowered, then well assembly is lowered, so that all these small materials which might create problem to the screen will be removed initially at the development stage rather than at the final stage. So, this is done by circulating hole with clear water, that is cleaning of the well, surging, backwashing, jetting, etc. And where the mud cake does not break up of these methods, means there should not be any damage when we are putting the water there or circulating the hole with some water, fresh water. No damage should occur to the already existing hole, and by treatment with chemicals like sodium, hexametaphosphate, etc. Some chemical treatment. But one thing which before I end this discussion, one thing I would like to say in a different manner, that in hard rock terrain, drilling is expensive, it is a slow process, but lot of problems in future would not come if water is available in sufficient quantity. Then the problem of such sediments are coming, screening is getting blocked and contaminations are coming may not be very common. But in soft rock terrain, in unconsolidated sediments kind of situation like in Indo-Gangetic plain, the drilling is not much expensive, relatively quite cheap, very cost effective, economical. But later on the cost of developing the well completely for final production may require more considerations, more attention in terms of fine sediments, in terms of gravel pack, in terms of blank pipes, in terms of screen pipes and so on and so forth, or even the packing of the bottom of the well. So, that kind of thing, or cleaning is also required much. So, that kind of situation might be there. So, this is a kind of trade off. Soft rock drilling is fast, but rest of the arrangements have to be done. In hard rock drilling is costly, but rest of the arrangement, minimum arrangements are done as part of well assembly. So, with this I end this discussion. Thank you very much.